4 groups for this subject, but due to recent arrangement, so we reduced into 3 groups only. So Dr. Noh Khairana will be no more here. This subject will be conducted by me, Mr. Ibrahim, Dr. Syarah Sikin, and Dr. Ahmad Hafiz Nazib. So group 1, group 2, and group 3. Okay, this subject consists of 4 credits, 3 from lecture, 1 from your lab. Okay, 1 from your lab. Okay, if you refer to your timetable, it should be this morning will be your lab session, but it is more probable if we conduct class first, then lab to come over after that. So that's why I plan to change from the lab. We change into class, and the class and the class later on 12:30, is it, or 12 o'clock? By right, from my timetable, your lab or this morning session will start at 9:30, but I'm not sure why it has been changed into 9 o'clock. So we'll stick with the recent timetable, then no problem. But this afternoon class, which should be the labs lah, because the lab should follow our class. Should be 12:30, I think. And so for our MCO or our recent arrangement due to MCO, so our online class, actually the class we provide 2 hours for synchronous, then another 1 hour asynchronous, which you can see that it was to be held at night, and then we have 2 hours of lab. So every week you should have 2 hours of synchronous, 1 hour of asynchronous, 2 hours of lab. But for online approach, we've been provided 2 hours, but we going to meet only 1 hour, and it should be only 1 hour sufficient to represent 2 hour face-to-face. 1 hour or 40%, and 40% minimum of online basis is equal to 2 hour of face-to-face meeting. So the subject will be conducted around 1 hour like that. And so I plan to adjust the night asynchronous class into our 2-hour meeting as well. So another half hour for night class and 1 hour for morning class. We combine together, so 1.5 hour. So no more night class. Are you okay with that? So because next week will be our Ramadan, so I wouldn't want to disturb you on night time. We can go for Taraweh. So we shall draw, or we shall adjust all the night class into our morning class. And morning class means that the lab hour we replace with lecture. The lecture hours we replace with lab. And so in terms of lab, I shall. We have we explain about lab later. Okay. For this subject, polytechnic 1 will be me, Dr. Khazana, Dr. Syarah Sikin, and Dr. Ahmad Hafiz Nazib lah. And the technician and the assistant engineer involved, Puan Siti Najihah, Encik Azliman, and Cik Azizan. Wait, maybe a little bit change here. We'll note you all later. Okay, this is the profile that involved with the subject. Within the syllabus that we taught you all, you should be able to gain the knowledge profile of WK4, 5, and 8. Or the knowledge in terms of specialist knowledge, the design, literature is involved in this subject. So in terms of the depth or the complexity of your subject, We cover WP1 to WP3. Okay, for this subject, we have 4 CO, a little bit rearrangement from the previous year's CO. Previously, we have 3 CO, but this semester, we have rearranged into 4 CO. And we have 4 CO here. The first is by the end of this subject, you should be able to analyze power electronic converter topologies and operation. So we shall have rectifier, which is AC to DC. We shall have DC to DC converter. We shall have a DC to AC inverter. So you should able to analyze the topology and how the switch operate in terms of how you want to produce the DC, how you want to produce the AC out of DC, and all the converters. So in terms of how the operation of the switches. Then CO2, you are able to identify, analyze the protection circuit of power converters. Because in power converters, when we learn power converters, we should be able to indicate how big the switch you want to use and how to protect the switch or the system such that it can operate all the years or all up to their warranty periods. We are not expecting you all to design, you test, and cannot be used. So we have to analyze the protection circuit for the circuit itself, for the system itself. And then you are able to design power electronic converter system. The first one is just the concept, how the topologies work. And CO3, you will go deeper, how to design in terms of how to control the switch and what kind of power, what kind of voltage current that you have to supply, how long the duration duty cycle. So the overall design of power electronic converter system. How big the inverter, the inductor you want to put in, how big the switch, and what switch you want to select. Okay, so this is to be covered in CO3. And CO4, you are able to investigate and evaluate power electronic converter topologies and performance through theoretical and simulation. So you have learned throughout the class here regarding the topology, the protection or the sizing of your converters, switches, and also the selection of your devices. Then you should be able to simulate. So here you will use, you will perform your CO4 here in your lab. And instead you are able to simulate using any kind of simulation tools. So the link that we shared to you all previously was the link for PSIM. That was the evaluation version. Previously we used student version, but it has limited data points. So we have request limited time of evaluation version for you all to use. So make use of it, benefit it maximally. So you can use any kind of simulation tools such as PSpice, LTSpice, which is available online. And you can use MATLAB if you have your student version as well. So any simulation tools can be used within this subject, such that you are able to show your understanding on the topology and performance of the converters. Okay, this is the POs that each of these CO will be mapped to PO, means that the program outcome of our subject, you should be able to support PO2, PO3, and PO4 as indicate here, the statement on the PO2, 3, and 4. Okay, in terms of labs, so previously we focused on PSIM, but this semester, the experiment will be in general, is that we introduce you all to software. So initial we shall use PSIM, but later you can use MATLAB, you can use LTSpice, you can use PSpice, whatsoever, which is available. So introduction to software will be on week 1 and 2. Then it follows by AC to DC converter, and the DC DC converter and DC AC inverter. And then lastly, the protection and device circuit. So we shall have 5 labs throughout 14 weeks of our study. Okay. If you have any question, you can raise your hand, or you can ask. You can switch on your mic. You can ask, or you can type inside the chat box. Okay. We shall proceed. Okay, in terms of textbook, we shall use William Hart as previous years, 2015 from McGraw-Hill. So Daniel William Hart. Most of the reference examples will be discussed from this one. Also, we can use Harun Rashid, electronic circuit and device application from Prentice Hall. Okay, we skip this one first. This is the SLT. Okay, regarding SLT, actually, as I told you before, by right, our lecture, if we meet by face-to-face, it should be 2 hours here. But once we conduct in online, during online, so it should be only 40% of your 40% of the meeting hours. So we set that 1 hour. Meanwhile, asynchronous, your night class 40%, instead of 60 minutes. So it shall reduce to 24 minutes, around half hour lah. So I plan to lump the asynchronous into synchronous hours. So we shall meet during morning class 1.5 hours. So there will be no more night class lah. Okay, in terms of laboratory, we shall proceed same 2 hours, but maybe I will come in during 10 minutes early of the class for briefing, and I leave you with your simulation and your work. So I come in another maybe 10 minutes before we dismiss. So total you will engage with the laboratory session 2 hours lah. 2 hours. So there will be a tutorial. If there is no lab, so there will be tutorial session. Discussion we don't have actually. We shall delete this one. Okay, we have 14 weeks. So polytronic concept will be conducted or will be briefed within this week by right. And then we go to DC, AC, DC converter, rectifier, AC to DC converter. And rectifier regarding R load, RL load. Also there will be labs, introduction to software for week 1 and week 2 lah. So AC/DC converter will cover about 4 weeks. For 3 weeks. Your mid-sem break, which include Hari Raya, will be on the 6th week. So we shall have AC/DC converter topic up to week 4. Week 5, we come into DC/DC converter. And then we cuti raya. Come back, we continue with DC/DC converter. So DC/DC converter, it consists of 3 weeks. And DC/DC, DC/DC. Then the 9th week will be DC/AC inverter. Inverter will cover 4 weeks. And the remaining 3 weeks will be topics of protection of devices and circuit. So here we shall learn about how to select heat sinks, the concern of thermal management and the snubber circuit of your device. Okay, in between your lecture, okay, here's a lecture, you have labs. So you have 2 hours, 1.5 hour lecture, 2 hours lab each week. So week 1 you have lab, week 2 you have lab, week 3 you have lab 2, AC-DC converter or AC to DC rectifier. So the lab is to focus on the, okay, show you. Okay, the lab, in terms of assessment, the lab will not be assessed. The lab not going to be assessed. Even though inside the lab, you shall see the portion of marks given there. We have marks, but that is only for your reference in terms of when you want to discuss the answers or when you want to paste the graph. So the portion of mark represent how complex or how depth we expect you all to present your result. So the assessment only will be conducted on OEL 1 to 4, but we have just here. Only we have 3 OEL, OEL 2, 3, and 4. This OEL will be omitted. So we shall have 3 OEL, open-ended labs. Means that you shall have a problem given. You shall use the lab that you have conducted prior to this OEL, or OEL need just like an assignment lah. And so you will perform this assignment using the experience or the lab you have conducted previously to solve the assignment here. So we have DC-DC assignment, OEL. Means that, what does it mean by OEL is that by right we expect you all to come out with many or not from the same source of reference lah. And so you can come up with any kind of reference, any kind of data, any kind of raw data, any kind of device sizing. So at the end of the result, you shall have a different kind of solution and different kind of solutions or result of your project lah. And okay, so we have 3 OEL, DC-DC, DC-AC, and protection. And then you shall have a test 1, 2 question only, test 1. So OEL ni kita akan distribute within the 14 weeks. So maybe after 3 weeks, like being highlighted inside this timetable here. So OEL 1 will be given here. Actually, it's not given here. This is the time when you need to submit the OEL 1. The question will be distributed before the 4th week. And so in the meantime, you conduct your lab, you shall gain some knowledge or ideas on how you want to solve your OEL, open-ended lab. So all the assignment, tests, OEL here will be conducted or will be assessed individually. You can discuss among you all, but you have to present the assignment individual basis. Okay. So this is the submission date, OEL 1. We will provide you the exact date later. Then OEL 2 question will be published after that. So test 1 will be held here, week 7, test 1. We shall book the date. So it should not be, maybe not on 17 lah, 17 lah. We shall see where the location that available. So anyhow, we plan to be held on week 7. Then OEL 2 on week 8. And OEL OEL 3 on week 12. So we have distribute all of this OEL between your learning weeks. Okay, regarding your next assessment, which is test 1. Okay, test 1 week 7 and OBE. So for this recent situation, we don't have any kind of final exam face to face. So you shall have online exam, open book exam, OBE, open book exam. So you can open your books or notes at home and answer the questions, your exam question, but not to discuss lah. And we know we have catch previously students which discuss among their friends during exam lah. So we should not perform that kind of unethical behavior on this subject. So I believe you all not among that kind of student lah. So we given you all some kelonggaran lah, and to refer your books or refer your notes, but not to refer your friends lah. Okay, not to refer your friends lah. So by right, if you perform this kind of assessment, you should able to score lah. But if you do unethical behavior such that you discuss with your friend, so it's not a correct way. Okay, so the OBE will be conducted, OBE 1 on the week 10. So in the 3/4 of your learning weeks. So you have ample time to study. And so previously we lump all the questions inside final exam. So here's the chance for you to score because OBE 1 will be held on the week 10. Then OBE 2 only comes on your examination weeks. So you have more than 5 weeks to study and for your OBE 2. Okay, that's all for our assessment. So by right, this should be 10 marks. So OEL, we have 3 OEL, we have 1 test, we have 2 OBE. Okay, 10%, 10%, 10%, 20% for tests, another 50% for your open book exam. Okay, in case you are here, you can come over to see me at this place, block 2, first floor, room number 2, just beside Mr. Hasnizam's room. Or you can text me 010-525-3155. So I'm in charge for group 1. Group 2 and 3 is Dr. Sharashikin and Dr. Ahmad Afif Nazib. So you have any question, you can ask me. Any question from the floor? If not, we take a few minutes, then we come into the first lecture. Any question? So regarding your PSIM, you can use the link that I share inside the WhatsApp group. So you can use that one and you can explore, and also you can use and download LT Spice. I try to find the link, or you can Google from your web regarding LT Spice. Last year when I checked, the LT Spice is still available. I'm not sure within this year is it being still available or not. So you try to check, because LT Spice already moved into new owner of analog device, no more linear technology own the simulation tools anymore. It's still available, I think. You can Google the web for LT Spice downloads, and you can try to perform using the lab module that we have uploaded to the Google Classroom for the reference. Is there any question for this syllabus? Okay, if there's no questions, so we shall have a break, a few minutes, 10 minutes break. We shall come in again about 10, 10 o'clock. Okay. Okay, guys, welcome back. So everyone's okay, yeah? Still 24%. By right, your group should be 80%, I think. 80 or 60 lah, actually. But I'm not sure why still we have about 30%. I'm not sure where is another 70%, but anyhow, we shall proceed. So, okay, is there any issues if we shift the lecture class into our lab hours, morning 9 to 11, then the afternoon session we use for afternoon session we use for lab. So means that we proceed with lecture, then follows by lab. Should be no issues, huh? If you have any concern, so please raise your concern. Because previous year we have a few groups for the lab, so we cannot do that. So but this year, when our management they said all can attend the lab in one session because we conducting the lab online as well. So we have chance of replacing the lab with lecture and vice versa. Okay, if you take a look at your first note. Okay. So here is your first note. Introduction to power electronics. So this is the 2016 reference from Dr. Faridun, but almost the same Okay, it's just the introduction for the subject. So if we update the note as well, it become the content is almost the same. So why we need to learn power electronics? So we have two version of power electronics which offered by Unimax. So first is power electronics 1, the basic of power electronics. The advanced version of power electronics is on power electronics 2. That's the elective course. This is the core course that you have to take because either you wish or not. So this kind of syllabus or this kind of concern you shall have to face in your near future careers, because all of our applications out there, even though you are not going to work or you're not going to join industry, but howsoever in our daily consumer life, we shall use all kind of equipments which connected to electrical source. So all the electrical source device or apparatus or equipment, they shall use power electronics parts, and systems. Okay, we shall have in terms of normal daily device, components or appliance such as air conditioner, freezer, motors, vacuum cleaner, and that we use at home, all use power electronics. And also when we deal with our office appliance such as laptop, printers, computers, desktop, so we use power electronics as well. And when we drive or move from certain place to certain places, we use cars, motorcycles, and even now bicycles. We have power electronics application inside the appliance or the devices as well. And when we need energy at home, we shall generate from somewhere else and convert to our home through the grid lines. So we have some sort of renewable energy and generator from wind turbine, from solar panels, from hydro generator, we use powertronics. And when we want to control in terms of quality of our power, the grid line that converts the power from certain distance up to our traces, we want to ensure that the quality of the power delivered to us is at a certain par or standards. We use power.
Sir,
Ya.
kenapa saya tak nampak slide ya?
Oh, saya cakap seorang-seorang Sekejap sekejap. Sikit saya set semula. Nampak? Can you all see? I'm presenting the slide, powertronic slide. What color? Nampak tak?
No sir, tak nampak.
Tak nampak. Oh, sekejap. Nampak? Nampak kan? Can you see now?
Tak ada lagi. Sir.
Tu? Tak nampak juga? Wait, I change lah. Tap. Tap. Wait. Pasal pun tak ada kat sini ya. Window. Window. Boleh nampak?
Nampak sir?
Nampak okey ya? Okay. Just now I present the slide and on the side of the slide I put like a writing board lah. Tapi tak nampak kan. So now I only presenting the slide. Nampak? Can you see my cursor?
Can.
Okay, thank you. Okay, again, so this is the role of powertronics. We need powertronics in our daily life. Doesn't matter if we live at home, we commute to somewhere else, we work at office, or we deal with the power delivery itself. So all over the devices, appliances, there will be a powertronics converters. So when we talk about powertronics, we talk about converters. What to convert? We converting the power or voltage, and we're not converting the power lah. We're actually converting the voltage, and the P in is equal to P out lah. So the power is the same, but the things that we are converting is the shape of the voltage, and in terms of current, how much the load draw current. So it's up to the load capacity or load size. But in terms of voltage, that's the apparatus or that's the attributes that we are able to convert. So that's why when you talk about power electronics or power converters, we are talking about AC-DC, AC-AC, DC-DC, all the kind of conversion here. So this is the main things or main attributes inside our power electronics concern. So the role of power electronics is about power or voltage conversion actually. So in terms of application, it's applicable everywhere in our daily life. So what we need to do is that, or what we need to know is that, what kind of conversion that are applicable over there, and how we want to tap in or we want to contribute, or what are the basic things that we need to understand out of this power conversion. So that's what you shall learn inside this subject. Okay, as I told you before, power electronics is about power conversion, or actually a voltage conversion lah, because we shall convert from source to what needed by our load. Okay, let's say you are having your handphone. Inside your handphone you have battery. So the battery is the source, and your load maybe your keypad, your screen, your software, your ICs. That's your load lah. Antenna and all the things, the apparatus, the circuit. This is your motherboard of your handphone lah. So that's the load. So how you want to convert? Because your battery, at the first place, maybe the voltage is about 3.5 volt, but sooner or later it will degrade down to certain voltage lah, maybe 2.5 like that. But your load need 5 volts, and your board here need 5 volts. So what your converter need to do is that it has to maintain the 5 volt needed by your load, regardless any kind of voltage level reduce at your source. Okay, that is the role of your converter here. So you need to maintain the voltage that needed by your load, regardless any kind of voltage drop or fluctuation or deviation at your source. So how you want to do that? You have to convert using your controller. Okay, in terms of grid line, you have grid line, you have source, you have your load, which is you plug in and into your wall plug, switch outlet socket. So maybe it's your fan, your vacuum cleaner, your freezer, maybe your air condition. Here you plug into your socket. What you expect from your grid is that it maintains, because our TMB source here, we have plus minus of plus 5%, if I'm not mistaken, minus 10%. It fluctuates between 230 volts. Cannot exceed 10%, it cannot reduce more than 5% like that lah. Okay, how we want to do that, or how it was performed at our lines. So previously, maybe we use a multi-tap transformer, such that at our incoming, at our switch socket outlet here, it maintains within that range. Maybe something happened at your source, at the grid line, so the multi-tap transformer will tap higher or lower, such that the output to your switch socket outlet is maintained at plus minus 230 volt. Okay, previously we have this kind of multi-tap transformer labs lah in our syllabus, but due to MCO, we omit all the hardware labs. So we changed into our software lah. So no more to simulate that kind of multi-tap transformer lah. So this is the role of power electronics, to maintain or convert from your source into your required load. That's in terms of voltage levels. But sometimes the load needs only DC voltage, but incoming is AC. So that's why we need inverter. We need a rectifier from AC to DC. So the converter will convert from AC into DC. Sometimes we have a source which is DC, like solar panel DC, but our load motor we need AC, so we have to convert from DC direct current into AC alternating current. So that is the work for converter. And so the converter will convert in any kind of this kind of pattern from AC to AC, from AC to DC, from DC to DC, and from DC to AC. Okay, this is the role of electronics. So it applies everywhere. We have renewable based electric generation from solar panel, from wind turbine generator, from thermal. Actually, our hydro electric dam also is renewable energy and renewable energy electric generation. So we have application in future. Recently also we have electric vehicles. We can see anywhere, especially in urban area, we have hybrid electric vehicles. In place maybe not so much lah, because we need to some sort of recharge station. Electric and hybrid vehicles, scooters, bicycles, all the EVs here available with battery rechargeable. It converts from DC into pulse width modulation voltage source to drive your propulsion motors to drive the vehicles. So in terms of improving efficiency, we need power converters as well, and improving efficiency. So in terms of information technology, so in our data bank or our processor room, master frame data room and servers. So we need DC source, huge amount of DC source. So information technology we have, and we have utility application, grid, multi-grid, grid lines, wise power regulations. So this is the construction of wind turbines. Which consists of 3 blades here, means that this is the high wind speed wind turbine type of application. We have a shaft which turns in high speed and it reduced by this gearbox, and it will turn the generator here, and maybe an AC generator, maybe a DC generator. So what happens that this wind turbine rotation RPM cannot be controlled. We cannot control, and it's up to the wind. High wind, you have higher rotation. Low wind, you have low rotation. So means that the rotation of this gear and this generator itself will be fluctuating, maybe high, maybe low, maybe high, maybe low. So what happens that you shall not, if you connect directly the generator into the grid line, you shall have a fluctuation of voltage and generator voltage. Maybe sometimes very high, sometimes very low. So you cannot stabilize and in terms of power that you deliver to the grid. So what happens that we use power electronic converters. So the usage or the purpose of this power converters is to regulate the power. So the generator itself, it generates maybe for AC from 10 to 60 hertz. Depends on the rotation of your wind turbines. Then what we need to do is that connect to the power electronic converters. It converts into a stable 690 volt AC, and this is maybe from AC into DC, then the DC converts again into stable AC, then step up using conventional transformer, linear transformer into 33 kilovolt, then step up again into 132 kilovolt. The higher the voltage you step up, means that the lower or the smaller the cables, conducting cables, that we need. So means that the lighter lah, lagi ringan lah kita punya grid lines punya wires lah. Means that if we step higher voltage, so P is equal to VI, the amount of current will be reduced. So smaller current we need, so smaller wire we can issue or install. So that's why we transmit at higher voltage, such that the amount of current can be reduced lah. Okay, this is application in wind turbines, and some more in photovoltaic system, renewable energy which generate from photovoltaic. What happens that when there is a higher sun intensity, so you shall have a higher current generate from the solar panel. But let's say the intensity is lower, means maybe at morning or late evening, or when there is a rain, there is a cloud, so the sunshine will not hit directly to the panels. So the generating current, actually it was a current source panels lah. The current will reduce. Instead of 4, maybe reduce into 2, maybe reduce into 1, maybe reduce into 0.5 ampere. And so what happens that we need some sort of regulator as well, from DC to AC or DC to DC, before we supply to the grid. So this is the power converter that we need to assign before we transmit or convert into AC and transmit to the grid. Means that we have to stabilize, and the variable, the fluctuating kind of voltage we generate or we get from the sun before we transfer into the grid. So there's a need of power converter. Yeah. Okay, same goes to our electric vehicles. We have batteries consist of 12 volt, or we parallel into certain voltage, maybe 24, maybe 48 volt, depends on the technology of the vehicles or manufacturer. And this is hybrid vehicles, means that it power up from petrol and as well from battery. So we drive the engine lah. The fuel tank, the petrol will drive the combustion engine. Meanwhile, the battery will attach with maybe another electrical propulsion motors. So it work together. So what happens that the batteries will not maintain at the same voltage all the time. Maybe you have 12 volt. So 12 volt at full charge. Maybe at 80% of charges, it will reduce down to 11 volt. Maybe if you reduce some more, it will reduce to 10.5 volt like that. So what happens that when the battery voltage reduce, at the same time we need to power up the motor at the certain voltage that the motor needs. So that's the requirement of power electronics converter. So we have here the requirement or the importance of power electronics in hybrid vehicles or electric vehicles. And also in our agriculture or in the commercial parts, we need a apparatus or the what so-called the drive to drive the pump. Let's say if we tap directly from AC to the pump, we shall see an issues of surge current. And the current issue in our motors now, when we use AC motor, is the surge current. If you learn your electrical drive, or in our machine that we have learned before, when we switch on the AC motor, there will be in rush current about 5 to 10 times the rated current. Let's say the motor needs only 10 ampere. So starting current can go up to 50 amps or up to 70 or 100 amps. Depends on the efficiency of your motors. So when you start and stop with that kind of direct online application, what happens that you might break your pump, you might break your pipe, and you might break your wallet lah, because it costs so much when you start and stop. That's why when we can see that if you apply or we buy air condition at our home, conventional aircon, which has only start and stop direct online with the AC source here, we can see that our bills will plumbing up lah. Unless if we buy inverter kind of air conditioner, so the electric bills will be reduced significantly. Okay, here we need adjustable speed drive, means that it can gradually speed up from 0 up to the rated speed of the pump. So adjustable, ASD, adjustable speed drive. From AC, convert to DC, and DC before it feed up to the pump. So it will gradually increase. If this is DC pump, so it will gradually increase from 0 to maybe 200 volt or 300 volt that the pump needed lah. But if this is an AC pump, so this should be inverter. So it will increase gradually from maybe 0 hertz to 10 hertz, 20 hertz, up to 50 hertz of the pump required frequency. So in terms of percentage of electricity in our country or worldwide, we need or we use power to power up motors about 50%, more than 50%, and high voltage AC is 16%, lighting is 90%. So most of the motors are using electricity. So so there's a big area of chances or application on the ASD and in the market. Okay, when we apply this kind of ASD, so there will be an efficiency improvement. Like I told you before, if we directly tap to the pump from AC, it can work, but we shall have issues of efficiency lah. Means that the degradation of your pump efficiency will reduce very badly lah, compared to if you apply or tap in ASD to the pump. So you can raise up the speed slowly, and you can stop gradually. You will not face an issue of inrush current or inrush flows. So actually the internal part of the ASD is the power converters. So if you have AC here, so what the power electronic converters do is that it convert the AC into DC, and AC into DC. Then this DC, if the motor needs DC, so it will supply DC to the motor from 0 to maximum voltage that the motor needs. But if the motor needs an AC, so the converter will convert from AC to DC, then back to AC, to the range of frequency that the motor needs. So from the lower frequency up to the higher frequency. So in terms of lighting, so previously in the early age, we used incandescent bulb. So this incandescent bulb is just an element of heating coil. So like when we have a electric source DC, we put into the wires. When the wires heat up, it will glow into red hot element. So this is what happens inside incandescent bulb. Red hot. It not burns up because inside the bulb it contains only vacuum. But gradually after certain years it blows as well. And it will not corroded because the inside is a vacuum. But with this incandescent bulb, the amount of electric that it consumes is very high. So we move out into CFL, compact fluorescent lamp. So what happens that we use electric converters inside our CFL. From AC 50 Hz, we convert into pulses of kilohertz. it will spark, and between the terminal, which contain mercury dust here inside the CFL, in terms of efficiency, improve very much lah, and about 80% improvement. Then now we have already moved into LED to cater or to overcome the issues of pollution or toxic pollution due to mercury. And so we move into LED, and the LED, the efficiency is increased as well. The same inside here we have converter from AC of our incoming, we convert into DC. We don't need any high frequency DC here. We just need a 5 volt DC to light up LED. So we arrange a few of LEDs inside our bulb here. So the higher the arrays, the brighter the LED lah. So this is in terms of improvement in terms of lighting. So CFL, as I told you before, is 3 to 4 times efficient than the previous incandescent light. What happens that we tap in about 30 to 40 kilohertz into the terminals. Meanwhile, for LED, it converts only from AC to DC, 5 volt, sufficient to light up LED. Okay, in terms of information technology, we can see the evolution. And let's say your phones, you never see this before, but my age, we have seen this in the early 80s, 90s, year 90. This is year 2000, 2001. Now we come here. Higher, lower, 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 thicker, thinner, 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 heavier, lighter, lighter, lighter. So the phones become like this. Maybe in futures it's just a single sheets of paper for your phones. Same goes to your computers, from desktop to laptop and down to wall top now. Okay, and your television become thinner than ever. Okay, this is in terms of emerging technology which applies power electronics. And this is for information and transmission facilities. We have high voltage DC to transmit not only on AC grid but on DC grid as well. So this is flexible AC transmission system. So for HVDC, we convert from AC to DC, transfer in DC, higher voltage, lower current. Then at the end of receiving, we invert again into AC, lower voltage, transmit to the consumers. So this is actually now we apply from Malaysia, within Malaysia, Thailand joint ventures. We have HVDC station in Gurun, transmit to Sadao, Thailand. So in terms of flexible AC transmission system, we are able to control in terms of their voltage level, and we are able to control in terms of their power flow. So various devices involved, SVC, STATCOM, all the terms here, we go deeper inside utility application, so you can browse in this kind of abbreviations. Okay, why we need power converters? Because it will introduce in terms of efficiency improvement. And so when we convert the power into certain application load, so for sure there will be a loss. If we are able to reduce this loss, means that the efficiency is higher, and P in is equal to P out plus P loss. You are able to reduce the loss, means that your efficiency will be higher. Okay, so we shall see in our future notes or syllabus of how actually, what actually are the contribution of the loss in terms of device, in terms of system. Okay, maybe the losses from the system wise what are the main contributors and how to reduce it. And for the device point of view, what are the contribution part of the losses and how to reduce it. So means that if we are able to reduce the loss, and this loss is represented by heat, not only the cost, but heat. So means that if you emit too much loss, you are degrading the lifespan of your system or your device. So that's not good for the design. Also, if you have more loss, so the cost also will be high. And that's another point of view. So we shall take a look at that after. Okay, that's for the first slide of your powertronic one. So just introduction in terms of the importance, the role, and the application of powertronics inside your daily life and your future works. Okay, is there any question for this session? And your lab will be this 12:30, if I'm not mistaken. Okay. Any question? We have come to the end.